Hello, this is Paul Sisler, and this is my final presentation for INT 650 Interactive Systems Design for the Fall 2011 class. During this presentation, I will discuss the history of human-computer interaction and interactive systems design. While we look at the history of these two, we will also take an overview of the computer and its advancements from early beginnings until today. As we move forward, I will discuss the influence of human-computer interaction and interactive systems design, not only in the computer, but in today's technology as it applies to any computer-driven device. When one begins to talk about HCI, I think it's important to begin the discussion with computers and their history. Were it not for the computer age, known as the information or digital age, HCI would have no place. HCI is a relatively new subject. In fact, computers themselves are relatively new. The history of the computer is generally attributed to Charles Babbage, considered the father of the computer. He was an English mathematician, philosopher, inventor, and mechanical engineer who around 1812 originated the concept of a programmable computer. However, the machine that Babbage conceived is of a far cry from the computers of today. His analytical engine was a proposed mechanical general-purpose computer which incorporated an arithmetical unit, control flow in the form of conditional branching and loop, and integrated memory, making it the first Turing-complete design for a general-purpose computer. Babbage was never able to complete construction of any of his machines due to conflicts with his chief engineer and inadequate funding. It was not until 100 years later, in the 1940s, that the first general-purpose computers were actually built. The first fully programmable computer is attributed to Konrad Zuse, a construction engineer for the Henschel Aircraft Company in Berlin, Germany at the beginning of World War II. Konrad Zuse earned the semi-official title of inventor of the modern computer for his series of automatic calculators, which he invented in 1939 to help him with his lengthy engineering calculations. The Z4 was the world's first commercial digital computer designed by German engineer Konrad Zuse and built by his company Zuse Apparatebau between 1942 and 1945. The Z4 was used for calculations for work on the Grand Dixence Dam located in Switzerland. By 1967, the Zuse KG had built a total of 251 computers. However, due to financial problems, the company was then sold to Siemens. Most computers use the stored program concept designed by Hungarian mathematician John von Neumann. In it, you store programs and data in a slow-to-access storage medium, such as a hard disk, and work on them in a fast-access volatile storage medium, or RAM. This concept, however, has an attendant bottleneck. It was designed to process instructions one after the other instead of using faster parallel processing. A von Neumann architecture computer has 5 parts: an arithmetic logic unit, a control unit, a memory, some form of input-output, and a bus that provides a data path between these parts. A von Neumann architecture computer performs or emulates the following sequence of steps. Fetch the next instruction from memory at the address in the program counter, add 1 to the program counter, decode the instruction using the control unit. The control unit commands the rest of the computer to perform some operation. Repeat. Nearly all modern computers implement some form of the stored program architecture, making it the single trait by which the word computer is now defined. However, very few computers have a pure von Neumann architecture. Most computers add another step to check for interrupts, electronic events that could occur at any time. An interrupt resembles the ring of a telephone calling a person away from some lengthy task. Interrupts let a computer do other things while it waits for events. The defining feature of modern computers, which distinguishes them from all other machines, is that they can be programmed. That is to say that some type of instructions, the program, can be given to the computer and it will process them. While some computers may have strange concepts based on instructions and output, modern computers based on the von Neumann architecture often have machine code in the form of an imperative programming language. The particular sequence of operations can be changed readily, allowing the computer to solve more than one kind of problem. An important class of computer operations on some computing platforms is the accepting of input from human operators and the output of results formatted for human consumption. In practical terms, a computer program may be just a few instructions or extend to many millions of instructions, as do the programs for word processors and web browsers, for example. A typical modern computer can execute billions of instructions per second, called gigaflops, and rarely makes a mistake over many years of operation. Large computer programs consisting of several million instructions may take teams of programmers years to write, and due to the complexity of the task, almost certainly contain errors. The interface between the computer and the human operator is known as the user interface. It is this user interface that brings us to HCI. Human-computer interaction, or HCI, is the study, planning, and design of how people and computers work together so that a person's needs are satisfied in the most effective way. HCI is concerned with the man-machine interface. Every system equipped with a microprocessor has some kind of user interface for its operation. This is particularly so for those systems that require lots of interaction for its normal operation, i.e. computers and computer programs. Until the late 1970s, the only humans who interacted with computers were information technology professionals and dedicated hobbyists. HCI is an area of research and practice that emerged in the early 1980s, initially as a specialty area in computer science. This change was disrupted with the emergence of personal computing around 1980. Personal computing, including both personal software and personal computer platforms, made everyone in the developed world a potential computer user and vividly highlighted the deficiencies of computers with respect to usability for those who wanted to use computers as tools. The original and abiding technical focus of HCI is on the concept of usability. This concept was originally articulated naively in the slogan, easy to learn, easy to use. Indeed, it no longer makes sense to regard HCI as a specialty of computer science. HCI has grown to be broader, larger, and much more diverse than computer science. Research in HCI has been spectacularly successful and has fundamentally changed computing. Just one example is the ubiquitous graphical interface used by Microsoft Windows, which is based on the Macintosh, which is based on work at Xerox PARC, which in turn is based on early research at the Stanford Research Laboratory, now SRI, and at the Massachusetts Institute of Technology, MIT. Another example is that virtually all software written today employs user interface toolkits and interface builders, concepts which were developed first at universities. Even the spectacular growth of the World Wide Web is a direct result of HCI research. Applying hypertext technology to browsers allows one to traverse a link across the world with a click of the mouse. Interface improvements, more than anything else, has triggered this explosive growth. Furthermore, the research that will lead to the user interfaces for the computers of tomorrow is happening at universities and a few corporate research labs. Interactive systems design, or user interface design, is a subset of the field of study known as human-computer interaction, or HCI. HCI is the study, planning, and design of how people and computers work together so that a person's needs are satisfied in the most effective way. HCI designers must consider a variety of factors. what people want and expect, what physical limitations and abilities people possess, how their perceptual and information processing systems work, and what people find enjoyable and attractive. It is nearly impossible to talk about design and not speak of Donald Norman. Don Norman sees design everywhere. Norman's goal is to help transform design from art into an engineering practice with tools, formal methods, and rigor. At the heart of this approach is human and activity-centered design. All design, says Norman, whether of a product, a company, a service, or an experience, is ultimately aimed at satisfying human and societal needs. This approach requires the application of knowledge of cognitive science, engineering, and business with the skills and knowledge of the design field, helping companies produce products and services that satisfy human and societal needs, both practical and emotional. Norman describes the human-computer interaction in terms of the gulfs of execution and evaluation. Basically, this means that the user has a goal in mind and must reformulate that goal in terms of a plan that ultimately involves the execution of a series of actions on the system. These actions result in changes in the state of the system, which must be perceived, interpreted, and evaluated by the user. Computer system developers need to understand how human beings perceive, interpret, evaluate, and respond to these computer actions. The basic idea is simple. To get something done, you have to start with some notion of what is wanted, the goal that is to be achieved. Then you have to do something to the world, that is, take action to move yourself or manipulate someone or something. Finally, you check to see that your goal was made. So there are 4 different things to consider: the goal, what is done to the world itself, and the check of the world. The action itself has 2 major aspects: doing something and checking. We call these execution and the history of computation has seen a number of major things. The first is that the user population is growing. One way of illustrating this is the number of users on the Internet. In 1980, there were 100 sites registered. In 1990, there were 100,000 sites. In 94, the number had reached 100 million. And as of March 2011, that number has grown to over 2 billion. This means that there is now a huge international market for even relatively specialized products, providing that users can actually operate the system. The second is the application range is growing. From very specialized devices for calculating navigational aids and ballistic trajectories, we now have general-purpose computing devices. These systems are being applied to a vast range of user tasks. The problem now is that we are currently very poor at matching the systems we build to the users. Thirdly, the degree of expertise is growing. Users are more discriminating than they once were. The introduction of graphical presentation facilities has increased the stakes in user interface design. The impact of multimedia and the games industry is such that many text-based user interfaces lack the appeal of more